Hi, this is Karen Cangelosi, and I just wanted to talk to you a little bit about the project that I've been doing for our octopus project this semester. So let me just share the slides quickly. I know we're trying to keep it to 10 minutes. So I've been working on this idea of a framework for an open science minor, and I generated some learning outcomes that you can find on the Google document, as well as some course descriptions for some core courses, an intro course, a sort of sophomore level practicum course, and a junior or senior level advanced open science course. The plan is to eventually have full course outlines or syllabi for all of these core courses, and to think about a range of possible electives for a minor. But mostly what I've worked on this semester is to think about this intro course. And this is just some descriptions about the three courses. The introductory course would be for both non-STEM majors and STEM majors. And the description here is that the course being for both non-STEM and non-STEM majors would begin a little bit with the nature of science and then covering basic principles, values, the critical analysis, challenge areas, survey of methods used across the whole open science ecosystem. And so trying to think about covering all of these different kinds of open in a very general way so students kind of get a sense of what's going on here and to really embed the idea of open education in OER and using an open pedagogical approach is all part of what I would try to do with an Intro to Open Science course. And so the course would begin with what is science and how does it work? And, a hat tip to Sam Donovan, who had an original project idea of really getting students to think about the nature of science and compare that to open science. And I thought, what a great way to start an introduction to open science course. So thanks for the idea, Sam. These readings from UC Berkeley are really great, especially this social side of science, a human and community endeavor, which sort of implies that science is done for society and that humans and communities work together. And so getting students to sort of think about what did they think about science and how do they think about science differently when they delve a little bit more into open science. And so as they read more about open science, these are some sources like using UNESCO's site. And I love this article on institutionalizing open science in Africa because it has some really great graphics and it also has a really good introduction to what open science is about. And I think students could read the introduction and this very first section, even non majors first year students can handle this beginning part of this article that I think is really great. And this is one of the graphics here, this scope of open science, really getting a sense of the broad sense that open science is a lot more than just open data. That involves open hardware, open labs, crowdfunding, open infrastructure, citizen science, open innovation. So really getting this idea of what does open science encompass. And then they also do a good job of articulating these benefits or possible benefits of open science that involve scientific research itself, impact on the individual science, opportunities for rewards and recognition, networking, collaboration, as well as social and societal benefits of open science, scientific community, public trust, and for students to really get a sense of, wow, this is really great. Look at all this great stuff. How much of it is really happening? Is one of the things I really want them to delve into. And so one of the projects that could be an early reflection assignment, like how did you think about science before you started the class? What's the same, what's different, and what does open science contribute or not to your understanding of science in general? I think this could be a really good way to start. And then as we move more into thinking about processes, tools, platforms for open science, and get them to think about these pieces of open science, about open hypotheses and research questions, methods, lab notebooks, open data, to explore a range of platforms. As they delve into these platforms, they could be given different kinds of assignments that get them practicing and looking at what's there and having a sense of how is research done, what does it mean to pre-register a research question, why would you do that versus not, Why would you have a lab notebook that's open to the world versus not? And to get them doing a possible project where they explore this list, they try to find other platforms and tools on their own. They can create a repository. They could write descriptions about what each of these websites, tools, and platforms offer, how they may contribute to opening science. And then to maybe pick one or two to explore more deeply, like what are the pros and cons do you see for these resources? Like, do any of them cost money, for example, or are they limited in certain ways? And so to get them sort of thinking about how much support and infrastructure is there really for open science, and how universalized is that or not? And so students could also do maybe a possible blogging assignment, or getting them to create something so that they can put out there openly themselves. And so students could do some research that helps to illustrate like the extent to which open science is currently happening or not, how effective open science is at achieving the benefits, maybe what are the barriers that they're coming across for this wider adoption of open science, and the activity of creating collaboratively creating some work and putting out there openly is actually an open pedagogical approach. And so we could actually talk about that, like what is open education? What does it mean to be doing your assignment with an open pedagogical approach? What are the pros and cons to that? And what choices do you feel like you can have around that? And so we can also move into talking about open access publishing with some fun stuff like this video. I love this guy. I'm just going to play his 1.5-minute video because I think I have time.
Hey man, how's it going? Oh, great. I just had a paper published. Dude, congrats. That's awesome. It was in a pretty prestigious journal, too. Oh, wow. They probably pay you pretty well for that. Yeah. Wait, what? The journal. They published your paper. They must have paid you pretty well for it, right? Oh, well, no, the journal doesn't pay you any money. Yeah, but they're using your paper. Yeah, so? Well, like if you spent years writing a book, you sell the book, you get money for it. Oh, well, I do get paid to do the research. You know, I get grant funding. Oh, so the journal that publishes your paper, they give you grant money to actually do the research. No, the grant money comes from the government. So the journal doesn't pay for the research or the content that they're publishing. Are they some kind of nonprofit? Oh no, the largest academic publishing companies make like $20 billion a year. Really? Yeah, their profit margins are like 40%, which is higher than Google. So why don't they pay you to publish your paper? Well, I get something much more valuable than money. What? Prestige. Well, why can't you have both? Because it's not about the money.
Okay, I think it's really it's both amusing and also gets across a lot of the main points that we think about academic publishing. And so having students maybe create their own video to describe what they think is happening in the scientific publishing world, like maybe by interviewing scientists, or incorporating their reaction to this video by Dr. Glockenflecken video. What do you think are the reasons for this current publishing system? They could compare green, gold, diamond open access using this resource or other resources. They could think about open peer review. They could do some research about what does it mean to have articles reviewed in the open. How does academic culture influence the peer review process? So all of this is a range of possibilities. Maybe not every student would be doing all of this through the whole semester. And just going to end with another piece of the course, which would be the expanded connections to open science. What is citizen science? What is citizen science? What does open infrastructure mean? What is open government? Open hardware, open source software, any number of possible things that could be done with this. So thanks for listening. I'm going to end this here.